This is Roster IQ, a memory-driven agentic AI system built to analyze provider roster operations across two datasets. One is at the file and the pipeline level, and one at the market and transaction level. So at the UI level, we build this in the Streamlit, so the experience is simple and operational. The first tab is the Roster IQ, and this is where the user asks questions in natural language like why is the MD struggling, or are retrees actually helping in NY. The app doesn't just return a generic LLM response. Instead, a query enters a LangGraph workflow where a supervisor agent decides whether the question needs help from a pipeline health agent or a market analytics agent or both. So let me demonstrate it for you. Like this is a demo prompt in which these are the options the user can select for the most selected queries. Then we have an operational question tab where the user selects, where the user types his questions in natural language. Like suppose I write this question, give me a market health report for CA. And when I click on run analysis, the processing takes place. The query enters our LangGraph workflow. And as I said, it is decided whether this question needs help from our pipeline health agent or a market analytics agent or both. So the analysis has run successfully, and this is the market health report for California. As you can see, this is the multi-agent trace. And talking about the pipeline health agent, it focuses on struck roster operations, stage bottlenecks, duration anomalies, and operational risk. The market analytics agent, on the other hand, focuses on the market health, SCS chains, retra effectiveness, and threshold pressure. And their findings are combined in a context building step where we also attach memory history, the active alerts as well, and therefore before generating the final answer. As you can see, these are the operational evidence, and these are why these rows were flagged. And this is the memory comparison UI card. These are the active alerts that I was talking about, and these are the operational report generator. Let's say I choose the report scope as state, and I choose the Californian market. And when I click on generate pipeline health report, it will generate our report, and we can download it also from here. And the second part of our UI is the dashboard view. So it is where the users can explore market trends, the charts, the retry lift, stock operations, and the pipeline health visually. The visually tool that we have created is helpful here using Matplotlib and Plotly. You can see these are the different types of graph. This is the heat map with respect to the organization name and the stage name. This is the duration anomaly chart. This is the RO tracker. This is a state distribution by state. And these are multiple reports like market health report, retra effectiveness analysis, duration anomaly sweep, try struck ROs. This is our high risk roster operation, and these are our active alerts again. So the third part of our UI is basically the memory tab. This is where the user can actually inspect what the agent has learned over time, the previous investigations, entity history, the stored procedure and alert history and semantic concepts all are available in this tab. So basically the most important part of our project is the memory system, because that's what makes our agent smarter over time. So we have basically used an SQLite based memory with multiple layers. First, we store episodes, which are the past user questions and answers. This is our recent query which has been saved, and these two were typed by me few minutes ago. So these have been saved in the recent episodes. Thus, as we stored episodes firstly, then we store entity mentions so that agent can remember specific organizations, markets or roster operations that came up before. We also store recent investigations, which are the snapshots of important analysis run. I mean, that means if a user asks what changed in CA since my last session, the agent can compare the current result against a previous saved investigation and explain the delta instead of starting from scratch. This is the entire history that I was talking about. We can, let's say I click CA and tap enter. The tool is running here and it shows our records. Now we have a persistence procedure versions, like agents analytical logic can evolve over time without losing track of what changed. On the top of that, we also add semantic memory, which also explains why the certain records are flagged in alert memory, where proactive monitoring writes active alerts and historical alerts states back into the same shared memory layer. So this matters because the agent is not just answering one-off question; it is building an operational context. Over time, it remembers what was investigated and what changed, and what got worse and what improved. So, and which entities keep reappearing. So, instead of behaving like an stateless chat bot, the roster IQ behaves more like an operational teammate, a teammate with AI agent. So that is really the core value of our project. Memory turns the agent from a reactive assistant into a learning operational intelligence system, which have a very high utility in the market. This is what we believe, and thank you.